Okay, we have here today another integral from the MIT Integration Bee 2013. This is problem 25. We have the integral of 1 over x times squared x squared minus 2 dx. Okay, now there's a few ways I would normally do this. Now you may first notice it's in exactly the right form for like our trig substitution for secant if we just substituted x equal to secant of t. But also in this case, because it's set up so perfect, we could just go right to a formula for this because it's just going to be, because this set's just going to be arcsecant, but we just have a different input here because we have 2 instead of 1. But actually what I wanted to do instead was look at an alternative method where we just do this using a u substitution. So to start with, what I'm going to do is I'm going to make my u substitution for just this here, the square root of x squared minus 2. I'll come over here and substitute and write all this down, and then we'll go ahead, we'll take the derivative of this. So for du, I'm just going to use power rule on this. I can actually write this, just to set up the power rule, I can write it as x squared minus 2 to the 1/2 power. So differentiating this first with power rule, we get 1/2 x squared minus 2, and this becomes minus 1/2. But then we need the chain rule on this. Derivative of what's inside here is going to be 2x dx. But then just simplifying this, because we have this as minus 1/2, I can write this in the denominator. I can write it as square root x squared minus 2 here. We'll have this 2 here, and then the numerator becomes 2x dx. But then we can just cancel out these 2's, and this is going to give us our value for du. And then from here, just to set up this substitution, I want to create this value in this problem. So what I'll do is I'm actually going to multiply in an x here, just noticing that now we have exactly our du value over here. But I don't want to change it, so I'll multiply by x in the denominator as well. But now x times x over here, we'll just write this as x squared. And then coming back over here, I can just find my x squared value. So what we'll do is we'll square both sides. We have u squared equals x squared minus 2, or solving for x squared, we get x squared equals u squared plus 2. And now we're all set up for our substitution. So again, everything over here is du. So I'm just going to write this as du in the numerator, and x squared is going to be just u squared plus 2. But now this is in our form for arctan, so I'll just go ahead and integrate. This is going to give me arctan. But then this 2 here, I can write this as square root of 2 squared. So for our arctan formula, we need to bring this square root of 2 value into the denominator. So we'll have it as 1 over square root of 2 arctan of u over square root of 2. But I just need to back substitute in order to finish it off. And so for my final solution of this, we get 1 over square root of 2 arctan of this square root x squared minus 2 over square root of 2, add a plus c, and that's it. And just a quick note on this solution, this is equivalent to the solution you get doing your substitution for secant, where you'd have this in terms, your answer would be in terms of arcsecant. And what you could actually do is draw your triangle, and you could find other equivalent solutions to this. Anyway, I thought it was a pretty interesting alternative to the normal trig substitution. Thanks everyone for watching. Have a good day.